5.4a is on normal distribution, the empirical rule, and z-scores. So one special type of distribution of data is called the normal distribution, or the normal model. The normal model is often thought as the bell curve. And an example of that is this picture below. A bell curve happens when the data is unimodel, or it's single peak. So as you can see, we have one peak. And the distribution on each side of the peak is symmetric. So we have half over here, half over there. When a distribution of data is deemed to fit a normal model, the standard deviation is used to break up the normal model into defined sections. The center is labeled as the mean of the data and has a standard score of 0 due to the fact that it is 0 standard deviation from the mean. So what this means is our middle is our mean, and this is 0. Because we're 0 standard deviations from the mean. So this little piece over here, this is what we call the empirical rule. It's the 68, 95, 99.7 rule. So what this means is I'm going to go ahead and break this up. Okay. So each of these lines is an additional standard deviation away from the mean. So here's plus 1 sigma. This is plus 2 sigma. And this is 3. Minus 1, minus 2, minus 3. And again, sigma is our standard deviation. So what this over here says is 68% of our data is in between here. It's plus or minus 1 away from the mean. So if this whole thing is 68, this piece is 34%, and this piece is 34%. This next piece says between 2, we have 95%. So I want to find out just how much is in these regions. So we can think, well, we're going to do 95 minus the 68, and that gives us 27%. So these two pieces are 27%, and then we divide that by 2, and we get 13.5. So 13.5% of our data is here. So now I have 99.7% within here. So I want to figure out how much is here. So I'm going to do 99.7 minus my 95. And I get 4.7. When I divide this by 2, I get 2.35. So 2.35% is here, 2.35% is here. Now, how much is on the tails? Well, if 97% is in this region, that gives us 0.3% on the outside. So then I have 0.15% and 0.15%. And these numbers are going to be what we use down here. So let's look at an example of how we use this. Traffic studies have shown that the vehicle speeds on a certain portion of freeway, when there are no accidents or construction delays, follow a normal model with an average speed of 67 miles per hour and a standard deviation of 4.0 miles per hour. Now this symbol mu is another symbol for mean. So our mean is 67 and our standard deviation is 4. So let's look back up at this picture. Where does the mean go? The mean goes in the middle. And that is our 0. So what this means is I'm 1 standard deviation away. So 67, what's our standard deviation for? So 67 plus 1 is 71. If I add another standard deviation, I'm 75. And if I add another one, I'm 79. So we found these numbers by adding sigma to the mean. Now I want to go the other way. I'm going to subtract a standard deviation. Then I'm going to subtract another standard deviation and another one. So we added 4, plus 4, plus 4, plus 4, minus 4, minus 4, minus 4. All right, let's go ahead and make our dotted lines. That's 0. Okay, so from the picture above, we see that these two are 34%, because 68% is in here. This one is 13.5%, because 95% is here. And then I have 2.35, 0.15, 2.35, 0.15. All right, let's look at A through G. So this picture is just going to help us answer these questions. What percent of all vehicles travel over 71 miles per hour? Well, 71 is 1 standard deviation away. So I'm going to look 71 or over. So that's all of these. So we have 13.5 plus 2.35 plus 1.5. I didn't write what I said I'd write. 13.5 plus 2.35 plus 0.15. And that should give us 16%. B, how many are between 63 and 75? Well, here's 63, here's 75. We add up those numbers. 34 plus 34 plus 13.5, and that gives me 81.5%. Go ahead and try C through F, and if you want to try G, go ahead and try G. Now that you've had time to try those, let's go ahead and look at them together. So less than 67. Well, here's 67. 67 is the mean. That's our 0. That means half of our data should be over here. So we should get 50%. For D, between 55 and 63. Here's 55, here's 63. So we can add those up, 2.35 and 13.5. That's going to give me 15.85%. More than 63. 63 is right here, so I have 34 plus 34 plus 13.5 plus 2.35 plus 0.15. That should give me 84%. Less than 59. 2.35 plus 0.15. That's 2.5%. The middle 95%. So let's look back up here. The middle 95% is plus or minus 2 standard deviations. Is between what? Well, here's 2 and here's 2, so it's between 59 and 75. Okay, here's another example. Go ahead and I want you to try to do this one on your own. Remember that mu is the same thing as our mean or x bar. So go ahead and pause the video so that they can work on this on their own. Now that you've had time to try this, let's go ahead and do it together and make sure we're on the right track. Complete the normal model below, showing the dollar amounts and standardized scores. The cost for a couple to eat at dinner at a popular Italian restaurant follows a normal model with a mean of $32 and a standard deviation of 550. So our mean goes in the middle, and then I add 550 over and over and over, so I should get 3750, 43, 4850. And then I subtract 550, so I should get 2650, 21, and 1550. Remember, this is my 0. This is 1 away, 2 away, 3 away, 1 away, 2 away, 3 away. So let's go ahead and fill in all of our percentages in our dotted lines. This is 68%, so we have 34 and 34%. 13.5%. 2.35%, 0.15%, 2.35%, 0.15%. All right, so what percent is below 32? Well, 32 is the mean. How much is below? This is halfway, 50%. Between 32 and 48.5. So we can add up those three numbers. So 34 plus 13.5 plus 2.35, and we should get 49.85%. Below 21, there's 21. Below that, we have 0.15 plus 2.35, which is 2.5%. And above 20, oh, sorry, you can't see that. And then above 26.5. So up here we have 34 plus 34 plus 13.5 plus 2.35 plus 0.15. And that gives us 84%.